Hello and welcome to Logos Learning. In this video, we're going to learn how to multiply rational expressions. So what are rational expressions? Basically, a rational expression is a quotient whose numerator and denominator are polynomials. So you hear the word numerator and denominators and you know that this is a fraction, not a favorite topic in math. A fraction or a ratio. So before we delve into multiplying rational expressions, let's talk about how to multiply fractions. A reminder. Now, to multiply a fraction, you have to multiply the numerators together and the denominators together. Do we need to get a common denominator? You absolutely do not. You could get it if you want to, but you don't need it. Now, let's try this one. 1/2 times 3/4. 1 times 3 over 2 times 4. So we have multiplied the numerators and the denominators, which yields 3 over 8. Now, whenever you get an answer in math, you want to try to simplify it as simple as possible. Are 3 and 8 multiples of the same number? They are not. So this is the simplest answer right here. Now, the same rule that we applied to multiplying these two fractions, we're going to apply to multiplying rational expressions. However, before we start, it's really important to review the exponent laws. Now, we have the law of multiplication. So when you're multiplying two numbers that have the same base but different exponents, you basically maintain the same base and you add the exponents. When you are dividing, you subtract the exponents. When you have a fraction to a certain power, that power applies to the numerator and to the denominator. If you have a product b times c raised to a certain exponent, the exponent applies to each component of that product. And the power of a power, if you have a number or a base b raised to the power of n, and this entire thing is raised to the power of m, then you multiply the exponents. So it's really important to keep these rules on a cue card so that whenever you're doing any work in math, you have these rules accessible to you until you have mastered them and memorized them. And hopefully that will be at the end of grade 11. Now, let's apply this knowledge that we just acquired, or in some cases reviewed, to solve some problems. Now here we have two fractions multiplied together. I like to use a dot for the multiplication because if you write an x, then it can be confused with the variable x. So whenever we do multiplications, I either put the dot or I put the exponents or the fractions in a bracket. Now, let's multiply the numerators. So y squared times 8 is simply put 8y squared. Now 3 times y is 3y. Now here we have the coefficients divided, so we're going to put it this way, 8 over 3. And this is y to the power of 2 over y to the power of 1. So we can simplify that by using the division law. So b to the m over b to the n is b to the m, or the exponent of the numerator, minus n, so minus the exponent of the denominator. So I'm going to write it this way, y to the power of 2 minus 1, or 8 over 3 y to the power of 1. Or I'm not going to write anything, because whenever nothing is written, it implies that there's a 1 there. Okay? You can also write it 8y over 3, however you like to write your math. Now, next one. Here we have two fractions multiplied again, but as I look at this, I see a lot of common factors. I see that the 3 is a factor of 9. I see that there's an x squared here, there's an x here. 8 and 2 are factors of each other. So we could simplify before we multiply. So here I can cancel out the 8 with the 2. So we're left with a 1 here and a 4. I divided both by 2. 9 and 3, 1 here, and here we have a 3. We divided both by 3. X squared, let's deal with that later. So let's write it out again. Multiply the numerators and the denominators. So we have x squared times 4y to the power of 2. So 4x squared y squared. So this is what we're left with after I simplify it a little bit. Here we have a 1 and a y and a 3 and an x. So I'm going to write 3. I'm going to write the x first because I did that in the numerator, and y. Let's simplify. Coefficients together will just be 4 over 3. Now, x to the power of 2 divided by x to the power of 1 is x to the power of 2 minus 1. Y, same thing, 2 minus 1. What we're left with here is 4 thirds x y, or 4xy over 3, however you like to put it. And this is our most simplified answer. Let's move on. 4x plus 4 over 3x minus 3 times 6x minus 6 over 5x plus 5. Now let's try to factor out what's common in each one of these terms. So for the top one here, 4 is a common factor between these two terms. So this one and this one, we have two terms. So we can take the 4 out and we're left with x plus 1 over, we can take a 3 out of here and we're left with x minus 1 times, we can take a 6 out of here and we're left with x minus 1, and we can take a 5 out of both terms here and we're left with x plus 1. Interesting. So let's take a look at this quickly. Here, just as we took out common factors here, we can do the same thing here. We have an x plus 1 on the numerator and on the denominator, so we can cancel them out. And we can do that because this is all multiplied. If there was a plus or a minus here, or a division sign, we could not do that. Only when it's multiplied can we apply this. Alright, so this canceled out, that cancels out, great. What are we left with? Let's take a look. 4 times 6 over 3 times 5. And again, we can cancel out the 6 with the 3, 1 and 2, divide both by 2. So we're left with 8 over 5, and that is our answer. Did you expect to get this simple answer out of this complicated thing? No, but sometimes math can surprise you. Next question. 6m cubed over m plus 3, 5m plus 15 over 8m cubed. Let's see here what we can do. We can take out, divide both by 2, and we're left here with a 3 and a 4. Okay, and that's what we're going to do for now. So we have 3m cubed times, or divided by m plus 3, times, here if I look at these two terms in this numerator here, we have 5 and 15, and I see that there's a 5 in these two terms. So I can take the 5 out as a common factor, and I'm left with m plus 3. Oh yes, I can cancel something out. And here 4m cubed. Now let's take a look at what we can cancel out. Since this is a multiplication, we have m plus 3 on this side, m plus 3 on this side, they cancel out. Great. M cubed here cancels the m cubed here. And we're left with 3 times 5, which is 15. And that is our answer. Another beautiful surprise. Now you wait and see what happens here. Here, what I'm going to do, oh, ignore this one, by the way. Ignore this. This is nothing. I don't know how I got there. Let's take it out. Let's see if we can take it out. We can't. Anyways, we have a trinomial divided by another trinomial multiplied by trinomial over another trinomial. So what can we do here? Can we cancel anything out? Not the way it is. We cannot do that because we have to factor it first. Now, I factored it ahead of time because there's a lot of factoring, but I can show you how to factor one of them. I'm going to show you how to factor the first one, and then I'll just write the answers for the last 3. So suppose we have, well, let's take the first one, 2x squared minus 5x minus 3. So here when we have a an a here that's not 1, our factoring is done differently. So we consider this 2 and then negative 3. 2 times 3 is minus 6, and let's look at the middle term, it's minus 5. So I'm going to write down here. So we're looking for two numbers that would multiply to negative 6 and add to negative 5. So let's see, what are the factors of 6? We have 1 and 6. We have 2 and 3. Now, if I want a negative 5, so I'm going to make this negative. Plus 1 minus 6 is minus 5, so these two numbers fulfill this requirement. And plus 1 times negative 6 is negative 6. So these two numbers are the numbers I'm going to be using. And basically, when you factor a trinomial like this, you want to split the middle term into the two numbers that you've chosen. So let's do that. 2x squared plus x, or plus 1x, minus 6x, and minus 3. So we have 4 terms here. We're going to consider the first two and then the last two. If you look at the first two, what is common between them? Well, they both have an x. So let's take the x out. And we're left basically with 2x plus 1. Here, what is common between these two? It is a minus 3. So let's take out the minus 3, and we're left with 2x plus 1. Because if you multiplied minus 3 with the plus 2, it will be minus 6x and minus 3. So we return to this form. Now, the final answer is x minus 3. So you look at these two, and then you write down only one of what's in the bracket, 2x plus 1. So this is how you factor a trinomial where the a number is other than 1. Let's write it down. So I have, as I said previously, factored these on the side so that it doesn't take a long time. So the top one here factors out to x minus 3 and 2x plus 1. The denominator factors to 2x minus 5, and I've done it the same way as I've just shown you, and x minus 3. This one factors out to 2x minus 5 and 2x plus 1. And this one, the last one, factors out to 2x plus 1 and 2x plus 1. Now, again, this is multiplied, so we can cancel out whatever is common. So is there an x minus 3 somewhere on the denominator? Yes, this one with this one. 2x plus 1? Yes. 2x minus 5? Yes. 2x plus 1? Yes. So it all canceled. What's the answer? Well, if everything cancels, the answer is 1. So all this ugliness, well, whatever some people consider ugliness, is beautiful in my eyes. Whatever we had here, all equal to just 1. I hope that this video helped, and in my next video I'm going to do some more examples of how to simplify or multiply, rational expressions. Alright, bye!